Hey everyone, welcome back to the channel. So we were discussing problems from linked list, and the problem that we are going to discuss today is given a linked list of 0, 1s and 2s. You have to sort it. I'll just quickly check if we are live. I think we are.
What if I tell you?
Yes. Okay. Cool then. So let us start off with the problem. Let's have a look. So as you can see, you have a linked list which contains only zeros, ones and twos. Okay, they can be in any order. You have to return a linked list in which all these values are in sorted order. So you'll have zeros and then ones followed by twos. That's how you have to return it, right? So let's understand how we can do. I'll just take an example. For example, you have like this. For example, you have a linked list. Just a second. 1 1 2 2 0 1 2, right? Let's say we have this. Now what? One thing is the brute force approach can be the brute force, not even, yeah, okay. One approach can be that you traverse over the entire linked list. Okay, as you traverse, you calculate, you keep three counters in which one will count number of ones, number of zeros, number of ones and number of twos, right? For example, this is what you have, and you go ahead and calculate how many zeros you have, how many ones you have and how many twos you have. Based on that, you again traverse through your linked list. So when I first traverse through my linked list, let's say count 0 is keeping the count of zeros, which is 1. These are the variables. Count 1, after all the traversals, whenever I find 1, I increment the count of 1, it will be 3. After by the end of the entire traversal, I will have count 2 equal to 3, right? 3, 3 and 1. Now next step will be what? That I will traverse over this linked list again. Right now this is my head node, right? So take a temp variable pointing to head. Check if, don't even check, you just simply do one thing, that change the data of these nodes with the number of zeros you have. If, see, the count of 0 is 1 right now, then what you'll do, you'll just simply do temp dot data equal to 0. Why? Because count of 0 is 1, and simultaneously you will reduce the count of 0. It becomes 0 now. Then your temp moves to the next pointer. Right now this got converted to, this one got converted to 0. Now your temp is at next pointer. So next pointer is what? You don't have to check what is the next pointer. You just need to check the three counts. If your count of 0 is 0, then you check for the count of 1. It is still greater than 0. So you will make your temp dot data. Now your temp dot data will be, it will go in the other if condition. First if condition, if count 0 is greater than 0, then you replace the temp data with the 0. Otherwise, else if count of 1 is greater than 0, right, then you do that and also simultaneously reduce that particular count by 1. Fine. Why we are doing so? Our simple aim is to, as long as how many zeros we have, I will replace the data with 0. When 0 gets exhausted, the number of ones I will have, I will replace that data with ones and then remaining with twos, right? That's my aim. Now count of 1, so I will make this 1 and reduce the count by 1. It will become 2. Now temp moves to the next pointer. I'll check count of 0 is 0, so you'll check count of 1. Count of 1 is greater than 0, so you replace this data with 1 and reduce your count to 1. Temp goes to the next pointer. The count of 1 is still greater than 0, so you replace this data with 1 and your count becomes 0. Then your temp goes to the next pointer. You check count of 0 is 0, count of 1 is 0, so you are only left with count of 2, which is 3. So the number of count 2 you are left with, you will replace that all the remaining data with 2. Becomes 2, temp goes to the next pointer, count 2 becomes 2, same thing, and your count finally will be 0 by the end of all traversals. Okay, and also you will make sure when you first point to this node, right, see, your head will still be pointing to the same data, same node, just that the addresses and links will be intact. You are only changing the data, right? So when you return head, you will actually get the linked list which starts at 0 and ends at 2. So this is one approach. The problem, or not even the problem, the thing is, we can optimize this approach. First of all, where is the optimization needed? See, first I am traversing through this entire linked list for counting the number of zeros, ones and twos, right? One traversal is that one. Other traversal is when I am traversing through the linked list again and changing the data when I am doing this part. So basically I am traversing over this linked list 2 times. So although my time complexity will still be big O of n, but I am doing it in 2 traversals. Is it possible to do it in one traversal? So yes, the optimized approach would be to do it in one traversal. What would that be? So in one traversal, the aim of this approach would be to actually divide the linked list into 3 different parts, one containing zeros, one containing ones, other one containing twos, and finally we will actually combine all these different linked lists, in which first linked list will be the one having the head of all the zeros, means the one linked list having all zeros, that head, then its tail will be pointing to the head of that linked list which is containing only ones, and the tail of that linked list will be pointing to that linked list which only contains twos, right? This is the aim of this approach. So 1 1 2 2 0 1 2, let me just quickly write it. 1 1, then 2 2 0 1 2, 2 2 0 1. I'll just check if you guys can see my screen properly and I have no doubts. Let me check it here. Are we not live or what? We are live, right? Yes, we are. Okay, so let's have a look at this one. The head is already pointing here, fine. So now my target is what? You take 3 different heads such that the head of first, for example, there is one head 0, there is another one known as head 1, other one known as head 2, right? And there is one temp node which is pointing at head right now. Temp node is pointing to head right now. Now I'm starting off with temp. So head 0, aim is that head 0 will be containing the linked list containing only zeros, right? Head 1 will be the head 1 pointing to that node which will be having only ones, okay, that linked list, and same goes for all twos. So first I check my temp dot data is what? Equal to 1. So first of all, I will make my head 1. See, this is the visual representation, not that actually I am dividing, not that actually I am creating 3 linked lists. No, it's just that I am adding a new pointer which will be pointing to the one of these nodes in such a way that links will be following only the same elements. You will understand it when I traverse through it. For example, first data is head 1. So ideally head 1 next will be pointing to temp, which is 1, okay, and then I will make my temp move to the temp dot next, right? Basically I always want my temp to be pointing to the linked list which I am currently at. So right now my head 1 is pointing to this is actually where my head 1 is pointing to. Now next data is temp. So, and also one more important thing is that you always try to maintain a pointer which is pointing to the node. Now this was, for example, my head 1, but you have to have one other temp head which is traversing through all the nodes or the tail node of this particular head 1. Getting it? You'll understand. One, give some time and you'll be able to understand. So for example, this is current one. Now you will have to maintain, actually these are 3 heads I already which I already declared. Now I will have 3 more heads or 3 more pointers which will be pointing to the nodes in that subsequent linked list. So let's make it cur1. Cur1 initially was at head 1. Now cur1 is at this. So next temp, now temp dot data is 1. So cur1 dot next will be pointing to this temp. So now again it will be 1, and move your cur1 to the cur1 dot next and temp to the temp dot next. Now see, in term, this is how I'm representing you, but ideally what has happened is that head 1 is pointing to this and cur1 right now is pointing here. Right, this is the visual represent, this is the actual thing that is happening into your linked list. Now this data is 2, and for example cur2 initially was pointing to head 2. So now head 2 dot next will be pointing to temp, which will be like this, right? So head 2 dot next is pointing to temp, and cur2 will move to cur2 dot next. So this is your cur2, and temp will move to temp dot next. Same thing will go ahead for all these 3 heads, all these 3 temp linked lists which we are trying to visually represent. But ideally your cur2 is now pointing at this one. This is where your cur2 is pointing, and head 2 is pointing, see, head 2 is dot next is this 2. So head 2 dot next, this is actually what is happening. Head 1 dot next is this node, head 2 dot next is this node, and cur2 is pointing here. Got it? Now move your temp to temp dot next. So temp dot data is 0, so your head 0 will be pointing to this. This is where your head 0 is going to point to, right? So head 0's next will be this 0, where your current 0 will be available, right? Current 0 was initially here, now it is moving to this pointer. So cur 0 is pointing at this node, this is cur 0. Move your temp to temp dot next. Until your temp is null, you are repeating the same thing and handling through these 3 different conditions. If your data is 0, what you are doing, if your data is 1, what you are doing, and if your data is 2, what you are doing. Now your temp comes at this node. What is the value? 1. So cur1 should be present at the tail of this node. So cur1 dot next should be pointing to temp, which is this another 1, right? So which was your current 1? Actually this is current 1, right? So cur1 dot next is now pointing to the next one, okay? And move your temp to, so right now your current 1 is not here, your current 1 is present here, okay? And move your temp to temp dot next, right? Okay, this is where your current 1 is. Now this is data 2. So your did I miss one data? Okay, I think I missed it. Next one is this 2, right, where your cur2 was already there. Now there is this another 2, so your cur2 will be pointing to this one, that is cur2 dot next will be temp, okay? And here is where your cur2, and then cur2 goes to cur2 dot next, temp goes to temp2 dot next, which is null. This is where you will stop. Once your temp becomes equal to null, you stop your iterations. Now see what must be happening. Current 0 is present at the tail of my linked list containing only zeros. I am repeating again, this is just the visual representation. Ideally the nodes are still intact, we have just added some few more nodes with some different pointers, so that I can know head 2 will always be present at that node whose data is 2, right? The first 2 that appeared in this linked list is where my head 2 will be pointing, and subsequently head 2's next will be pointing to the next 2, its next will be pointing to next 2. So this is what it tells me, that head 2 will be the list of series of nodes containing only 2. Same goes for 0 and 1s, okay? Now what, I'll just combine them. What do I want? I want head 1 to come after head 0, so that I will have all the 1s attached right after 0. So I'll do one thing, that cur 0 dot next should point to head 1 dot next, right? Next thing, this is current 1 which is at the tail of your linked list having ones. So current one dot next should be pointing to head 2's next, right? I want to get the node, the first node containing 2. So that will be head 2 dot next. And finally, cur2 dot next should be null. That is all about this problem. If you guys have any doubts, you can write in the chat. I just wish that I'm still live. Okay, we are already live. Fine. So did you get this approach? I will just write pseudocode so that you can easily understand what we have done here. Basically, we have maintained 3 pointers. Have a look here. I'm going to write the pseudocode. I have total 6 nodes that I'm defining right here. Head, see, head 0, node head 0 is new node. Let's assign some value -1. Same goes for head 1 and head 2. Okay, fine. Then I have some node that will be traversing through the list whose head will be head 0. Same goes for, so let's have 3 more nodes which are actually initially pointing to head 0, head 1 and head 2 to their corresponding heads. So let me make it cur 0 is pointing to head 0, current 1 is pointing to head 1 and current 2 is pointing to head 2. Fine. Now I am taking a temp node pointing to head. Fine. These are some declarations that I have made. Now while my temp is not equal to null, I am going to do this iteration. What I'm going to do, have a look. I will have 3 conditions. If my temp dot data is equal to 0, what do I have to do? I simply have to make my head 0, not head 0, current 0. Current 0 is the node that will be pointing to the tail of your linked list containing zeros. So right now current 0 is pointing to head 0 only. So current 0 dot next, a link should be created which will be pointing to temp. And then I always want my current 0 to be at the tail of that linked list. So visually just imagine it, how it is going to happen. For example, I have some 0, this is my head 0, this is my current 0 which it is pointing to currently, and in actual linked list also there are some node not going to create something like this. So basically that is happening. It will get very lengthy if I keep on doing it. Just try to understand. Current 0 is pointing to temp and current 0 equal to current 0 dot next. Got it? Fine. This is if your temp dot data is 0. You are going to repeat the same steps for current data if it is equal to 1, data if it is equal to 2. Okay. So if temp dot data, and one more I will write in else if conditions. Else if temp dot data equal to 1, then in that case you will have current 1 dot next equal to temp, current 1 equal to current 1 dot next. Same for if your data is going to be 2, current 2. Then I think I made a mistake here or not. Yeah, that is correct. Current 2 dot next is pointing to temp and current 2 equal to current 2 dot next. And then you have to move your temp to temp dot next so that I can move to the next node in my actual linked list, right? This is where your while loop will end. This marks the end of your while loop. Got it? Now after while loop, you just have to form the connections which will be of combining these all nodes which I have written right here. I am going to just take this as it is. Current 0 dot next will be pointing to, have a look. This is your entire code actually, pseudo code. after while loop you are doing these things, that will return you. And finally you return what? So if I see what must be happening, finally head 0 dot next is what you have to return. Head 0 dot next. That's all, guys. Fine. So we have done all these things in just one pass. So time complexity is big O of n. No extra space taken. We have just changed the links and taken some extra nodes. That's all about it. Okay. So let us have a look at the code now. If you guys have any doubts, you can ask me. This is what I have done, exactly what I have written. And just an extra check in case these are the nodes, head 0, head 1, head 2, the nodes which I have taken as current 0, current 1 and current 2, here I have taken them as 1, 2, 0, 1 and 2, okay, which are pointing to their corresponding heads. Then temp, as you know, this is the while loop I have written, the 3 conditions. And then after that while loop, how we are forming the links, it is that. Just that one extra check we have put here. What if the values are null? In that case, what would you do? That's all. That is the entire code of it. So we discussed 2 approaches. Both the approaches you can try. First, I'll suggest that you go ahead and try the first approach and then you move to this second approach. The problem with the first approach was that we were traversing through the linked list twice. So here we are not doing that. We are just traversing it only once and getting our things done in O1 of time complexity. So that's all about this problem. If you guys have no doubts, I'll wrap it up. I think we are done now. Okay, so that's all for today, guys. See you all in the next lecture. Bye bye and take care.